Hi everybody, my name's Andy. Bow ties are cool. Welcome back to Curiosity Corner Live. Every day at 10:30 we'll bring you awesome science content just like this. I'm going to show you a couple other reactions that you can find in the kitchen. Some kitchen chemistry quirks. So let's go to the kitchen. First effect that I'm going to show you is called the Leidenfrost Effect. I have a pan here. It's been sitting on this burner for quite some time. It's really hot. Do not try this at home. I have an eyedropper here with a little water in it. I'm going to drip some water on this really hot pan and we're going to see what happens. Oh, there you go. So instead of sizzling away, the drops of water just hit and you can hear that tink when they hit the pan and they start skittering around. And the reason this happens is when they hit the water, when they hit the pan, the water turns into vapor. And there's a little tiny cushion of vapor under each little droplet of water. There's a big one right there. All the other ones kind of soak up into that big one. There's a little cushion of vapor under those drops. And because there's that cushion of vapor, there's very little friction, and the drops skitter around, and I guess the pan is tilted in that direction because they all end up in that direction. At some point, the heat will get across that cushion of vapor, that cushion of air underneath the droplet, and it will start to boil away. It is actually starting to boil. You can kind of see it's bubbling and boiling, but it's boiling a little differently. Now what's really interesting, this is actually a physical reaction. This isn't a chemical change. This is the change of water from liquid water to gas, and that's a physical change. We can undo that boiling. Let's do that one more time. There we go, they all skitter around and they soak up into that droplet. Liquid nitrogen does this too, because liquid nitrogen boils about negative 320 degrees Fahrenheit. Water boils at about 212 degrees above 0 Fahrenheit. So if you get this pan really, really hot, water will do this. Liquid nitrogen will do this at room temperature because 70 degrees Fahrenheit is so much hotter than negative 320. And this pan is so much hotter. They're starting to get a little bit of steam, so I'm going to turn the pan off and show you our next reaction. Okay, the Leidenfrost effect was a physical change, but let's explore chemical change. Now, have you ever wondered why toast tastes toasty, or why a cooked potato tastes different from a raw potato? Well, there's a lot of different chemical reactions happening when something gets cooked. And a lot of that cooked flavor comes from a system of reactions, a bunch of different reactions that are sort of all referred to as the Maillard reaction. It was discovered by a guy named Maillard. So I'm going to explore that reaction. It has a lot to do with heat, and it has a lot to do with the different chemical compounds that are inside different foods. So I have a pan here filled with a little bit of olive oil, just a touch of olive oil. And I have a plate here of 2 stacks of onions, and we're going to cook those 2 stacks of onions, but 1 stack of onions, I'm going to add a little bit of baking soda, because the Maillard reaction has to do with compounds and different chemicals inside foods, but also with pH. And the higher the pH is, scribble a little of that on there, higher the pH is, the faster the Maillard reaction will take place. So let's pop these in to the pan and see what happens. Okay, narration, because it was sizzling really loud. Okay, I put the baking soda ones on top, right there, and the ones without baking soda on the bottom, and separated them out. As soon as I put them in, as soon as they started cooking, the ones with baking soda started to change color. They started to turn brown. That's the Maillard reaction happening really, really fast. So, I'm going to start a time lapse soon of them cooking the rest of the way, and we're going to see how fast that goes. Here it goes. There's the Maillard reaction in action. Alright, there you go. It's been a couple minutes. Quick time lapse there. You can see these, the ones that started to brown almost instantly after I put them in there. These are the ones with the baking soda. These are ones without baking soda. You can see these have browned a lot. These are browning a little, but not quite as much. The Maillard reaction is what makes a lot of foods brown, and it happens around 320, 330 degrees above zero. That's like the upper limit of the Maillard reaction, and it's why a lot of different recipes call for 350 degrees Fahrenheit, because that is the optimal temperature for the Maillard reaction to take place. I will dispense these into a plate, and I'll tell you how the two different onions taste compared with how fast the Maillard reaction took place. The baking soda made it go faster. The lack of baking soda made it take more time for the Maillard reaction to take place. So we'll see what happens. Alright, I have my onions. So I'm going to taste them. We'll start with the raw onions. That's an onion. So now let's try the ones that didn't have baking soda, just a touch of olive oil. It has that kind of roasted taste, so there definitely was a little Maillard reaction that happened there, but let's compare it to these ones that did have baking soda and got an accelerated Maillard reaction. You can taste the baking soda. I think I added too much baking soda. They're very bitter. But there is more of a roasted taste compared to these ones in the center. Definitely a lot of bitterness. So I have to refine the recipe. I think I prefer the raw onions, to be honest. They taste fresh. Anyway, thank you for exploring kitchen chemistry quirks with me and exploring the Maillard reaction, which I didn't know about for a long time, but it's really fascinating how that browning happens and that roasted taste, what that comes from. And also, my challenge to you is to try something like this experiment. Do not add so much baking soda, you will regret it, but you can experiment with cooking something simple like a potato or a onion with different combinations of baking soda or even lemon juice, different kinds of pH, acidity, or basicness, different amount of base. Or, simpler challenge, have fun cooking and exploring the chemistry there. So thank you very much for joining me on Curiosity Corner Live. My name's Andy, bow ties are cool, and stay curious. Actually, I prefer these ones are better.